This is our pre-calculus first 6 weeks final, and this will be for the 2017-2018 school year. And we're going to just go through these. I'm going to go perhaps a little faster than you would on your test in that I've pre-entered a lot of these functions on the graphing calculator in the interest of time. Problem 1, which of the following functions is bounded above and below? So you're looking for something, a function that has an upper boundary and a lower boundary, beyond which, above or below, this function cannot be exceeded. And so if you know the basic parent functions, the answer would already be apparent. But if not, we type these in one at a time. If we go to a graph button, we're going to press the trig button and put in sine x, and we can see that this function is bounded both above and below, and therefore we call this bounded, period, and our answer choice for this is B. Next, problem 2. For the following function, find the approximate interval over which it is decreasing. So the obvious thing is going to be to graph the function, which I have done previously in the calculator. So I'm going to get another page and go find that previously graphed function. I think I've got to go up a ways. And is this it? 0.1. I think this is it. Let's see. Yeah, this is going to be it. And so the function is decreasing from this relative maximum here around -1 all the way down here. So we can just trace this and see what's happening. If we go to trace, graph trace, we're going to go up to the left and see where we start. It says maximum. It said maximum where x equals -1, and then we go down to the minimum. That function is decreasing as we go past 4 and now to 5. It says minimum at x equals 5. So between -1 to 5, and sometimes you'll see this written with brackets as a closed interval, not an open interval. Nevertheless, C is the only remotely possible correct answer. Which following functions has a vertical asymptote? And this is a very easy one. When you graph this function to calculator, you would see that this answer choice C would have a vertical asymptote where x equals 2, and so the function is going to look something like this that I'm drawing now. So C is our correct answer. There shouldn't have been any dispute about that, especially with graphic calculator in hand. I don't see a very good excuse for missing that easy problem. 4. Each of the following functions has a discontinuity. Which one has a removable discontinuity? You can see in the numerators are all the same, x squared plus x minus 30. And so it's only going to be what's in the denominator that makes the discontinuity removable or non-removable. We should be able to see that where these discontinuities take place, but which one is removable. So there are different ways to do this. I'm going to go to the graphic calculator first. And what I did is I previously, I believe, entered answer choice B, and so I can go to Control I and get that. See what that looks like. Oh, there it is. That's answer choice B right there. So we press this and we get some kind of vertical asymptote. Okay. What you're looking for, removable discontinuity. So this disqualifies answer choice B. This is answer choice B entered. So we can go back here. If we'd enter this, we would cross off answer choice B. Now going back to calculator, I'm going to go to tab, and we're going to change this one here. I'm going to go all the way up. Okay, we're going to change this to answer choice A. And to do so, I'm going to put x minus 5 in the denominator. and we do that, we don't see any discontinuity, which is a sign of a removable discontinuity. And we can check, indeed, that we do have a discontinuity at x equals 5 by going to Control T, which is our table view. And if we go to an input of 5, we see an output of undefined. So that solidifies answer choice A as our correct answer. That's one thing, the types of removables and non-removable discontinuities. It's more drilling on that. Again, an asymptote question. Which of the following functions has as a vertical asymptote the line x equals 5? Well, before I do that, let me go back to 4. What happens, we can take this answer choice A and factor the numerator into x minus 5, quantity x minus 5, times quantity x plus 6. And what happens is this x minus 5 in both the numerator and the denominator will cancel each other, leaving x plus 6, which the graph of that we graphed looks like the graph of y equals x plus 6. Now this one, which of the following functions has as a vertical asymptote the line x equals 5? Well, in answer choice B, we can go ahead and put our denominator and set it not equal to 0. And if we add 5 to this, to both sides of the inequality, we have x cannot equal to 5, which qualifies for a vertical asymptote possibly, or a point discontinuity perhaps. But in this case, we all have vertical asymptotes, but where is the vertical asymptote? X equals 5. And if you graph this in a calculator, very easy. No one should miss a problem like 5. 6. Compare to the function y equals 3x minus 6, which is its inverse function. So to do the step process, if we take this y equals 3x minus 6, and if we change this to x equals 3y minus 6, we can solve for the new y, and we do that, we have on the left side x plus 6, on the right side we have 3y. And if we divide by 3, we have y is equal to 1/3 x plus 2. And our answer choice for that is B. And if you graph these in the calculator, very easy to spot a inverse function using the graphing calculator. If we graph this first function, y equals 3x minus 6, 1, 2, 3, 4, 5, 6. The original graph function would look something like this. A slope of 3. It would look something like this. And we want to see the line reflected about the line y equals x. So I'm going to draw the line y equals x. And then this answer choice B would be just like this. It would be just like this. And so these things, the blue line, the purple line, reflect each about the line y equals x. And very easy to graph on the calculator, or in this case even without a calculator. 7. What is the domain interval notation of the function shown below? And it'd be very easy to graph this. I didn't pre-graph this, but I'll do it right now. We have the square root of quantity 7 minus x, and we see we have a function that goes in domain from greater than negative infinity all the way up to and including 7. On these, continually watch for domain and range. They try to get you, us test writers, on these things. And since 7 is included in the domain, answer choice A is our correct answer for number 7. 8. What is the domain interval notation of the function shown below? And some people have trouble with this. One thing you can do is look at a graph in the calculator, which I'm going to do now. I go to Control I, add graph. I pre-graphed this one. Which one is that? There it is. You graph this, you see definitely a vertical asymptote, x equals 2. And were you not to look any deeper, you might be inclined to choose answer choice A. But if you go to Control T, you will see that you have not only a discontinuity at x equals 2, but you also have a discontinuity at x equals 0. Okay, at 0. So what that does, that separates the entirety of the domain into two discontinuities at 0 and 2. And so there you have your discontinuities and everything in between, and less than, and greater, less than 0, greater than 2. And where that fits in the answer choices is answer choice D. And then if you look for the denominator and set the denominator, in this case x squared minus 2x, not equal to 0, and you solve this, well, you have x times quantity x minus 2 is not equal to 0. You have x cannot equal 0, and also for x minus 2, x cannot equal 2. So an algebraic determination. Shouldn't have been too hard of a problem. More people missed it than should have. Which of the following functions has a range of the closed interval from -1 to 1? Well, we could have seen from problem 1, we have that sine x function. It's going to be answer choice B, and you just have to enter this in the calculator and look if you don't understand, if you haven't looked at the functions already or know what they would look like. A function is represented, 10. The function is represented by 3 sets of word pairs, 1, 2, 2, 4, and 4, 9. Which of the following sets of word pairs represents the inverse of that relation? Well, what you have is basically in inverses you have the coordinates reversed. So this 1, 2 becomes, in an inverse situation, 2, 1. And the 2, 4, taken at its inverse, is going to be 4, 2. And the last thing we have is 4, 9. Its inverse is going to be 9, 4. And our only answer choice for that is going to be D. 11. Which of the following rational functions has no discontinuities? Well, what's happening here, I'm going to go to answer choice B, and previously having entered answer choice B, okay, go here, go up to this, that's not it, there it is, and this graph has no discontinuities at all. And if you go to table view, you're not going to see an undefined at any point, but let's go ahead and explain how that happens. In this answer choice B, there is no number we can substitute in for x that will make this denominator equal to 0. You can just try. You can't. And so when you have an x squared plus something in the denominator, that is not going to produce a discontinuity in a function. Okay, 12. If f of x equals 2x minus 3 and g of x equals x plus 1, find f of g of x. Well, what is next to the x here? Well, it's g. So we take this g function here, this x plus 1, and we're going to substitute it into this one every place that we see x. So f of g of x is going to be equal to 2, and in place of the x we put in this x plus 1, and then we just have to not forget to also subtract 3, and then we simplify, distributing, we get 2x plus 2 minus 3, and then that simplifies to 2x, and 2 minus 3 simplifies to minus 1. So A is our correct answer for number 12. Should have been pretty easy, very easy. 13, which function is the inverse of the function f of x equals x cubed plus 1? And I've emphasized in my class a 4-step process, the first of which is going to be take this f of x and converting that to y. So I rewrite this as y equals x cubed plus 1, and now switch x and y. So now we're going to rewrite this as x equals y cubed plus 1. And now solve for y. If we subtract 1, we have y cubed is equal to x minus 1. And to undo the cubed on the left with the y cubed, we take the cube root. And here we have that. We have y is equal to cube root of quantity x minus 1, which simplifies to, I said, change back to f negative 1 of x. Well, in this case, we're starting with g of x. We call it g of x is equal to cube root of quantity x minus 1. So our answer choice here is A. And again, we could have reflected this about the line y equals x graphically like we did in that earlier problem with the 1/3 x plus 2 or whatever that was. 14, what is the horizontal asymptote of the function fx equals 3x cubed minus 2x plus 3 over 4x squared minus x cubed? And I'm going to go to the calculator first, and then we'll come back and analytically work that out. If we go to Control I, add graph, we go to, see if I can find that one. Where is it? There it is. We graph it, and we really can't tell readily what the asymptote is, a horizontal asymptote is going to be, but we can either go through trace or table view. If I go through trace, press menu, trace, graph trace, and if we just trace, okay, all the way, we can go all the way to the right or to the left. Okay, we have this thing coming up here, and what is it going to settle down to? Well, we have the thing going, and it keeps on going wherever it's going to come on down is what it's going to do. But that's going to take forever. But what you can do for that, that'll speed things up a lot, is you can go to a table view. Well, I don't know if it's honing in on -3 as a y value. Do you see that? And the farther out we go, the closer the thing is going to get to -3. And if you go to table view, you can look at it more quickly. But anyway, -3 is going to be our answer to this. Y equals -3. Another thing you can do is, when you consider this thing here, you take the highest, okay, your horizontal asymptote, you take y equals, you take the highest powered polynomial term. In this case, you have 3x cubed in the numerator divided by the highest power term in the denominator, which is going to be -x cubed. And these things are going to simplify to x cubed or x cubed cancel each other, so you have left -3. And that's because relative to the cube things, this negative 2x plus 3 in the numerator and the 4x squared in the denominator fade to obscurity the closer you go towards positive infinity or negative infinity. And I'll call this the little acronym BETC. And BETC stands for the bottom equals top, in this case, the bottom exponent of cubed equals the top exponent of cubed. Then you use coefficients. So 3 divided by negative 1. 15, what is the inverse function fx equals 2x plus 3 over x minus 1? There's a 4-step process to this, like I showed earlier, and that's going to be, we can rewrite this as y equals 2x plus 3 over x minus 1. Change that to x equals 2y minus 3 over y minus 1. Then we multiply both sides of this equation by y minus 1. On the left we have x times quantity y minus 1. And on the right we have y minus 1 over y minus 1 cancel each other, so we have 2y minus 3. Now on the left side we can distribute x to both terms here. We have xy minus x equals 2y minus 3. And now to solve, we're going to put everything with y on the left side by subtracting 2y from both sides, and everything without y in it to the right side. So we're going to add x to both sides of this equation. And we do that, we have negative x plus x cancel on the left side, 2y minus 2y cancel on the right side, and left over we have xy minus 2y. That would be equal to x minus 3. And then if we factor out the y, we have y times quantity x minus 2 equals x minus 3. But is that right? Okay, I guess it is. Then we divide by x minus 2, and we have x minus 3 over x minus 2. So that should be what it looks like. Let's go ahead and I graphed this thing previously, so that's going to be f negative 1 of x equals x minus 3 over x minus 2. And then we go to our calculator and we get, where is that? So this is the first function right here. We graph that, and then if we add to that the line y equals x, we want to find the function that reflects about this line y equals x. And to do that, I'm going to go ahead and add, go to tab, and I think we figured out that it was x minus 3, didn't we? Over x minus 2. It should be x plus 3 over x minus 2. Let's look at that again. Let's see a mistake in progress. Okay, we put down x plus 3. Okay, yeah, these are the reflections right here. Okay, so that's right. So there's something in this work that was amiss. Let's see, we minus 1 minus minus minus. We added x. Yeah, plus x. Yeah, what it was this. I just mistranscribed here. That should be plus 3, right? Plus 3, plus 3. Okay, so this all becomes plus 3 plus. So that demonstrates B is our correct answer. Next, 16. Which of the following parent functions has as its end behavior the limit as x approach infinity if x equals 0? Well, it's going to be this one right here. Okay, it's going to be this one, this 1 over x. If we go toward, in this case I'm drawing the arrow here, right, toward infinity, what does y approach? Well, it approaches this horizontal asymptote of y equals 0. So our answer is going to be answer choice A. 17. Which of the following functions exhibits odd symmetry? And we talked about this quite a bit. This answer choice B is a square root function and has neither odd nor even symmetry. D has a cosine function has even symmetry. It looks something like this, even symmetry. Your quadratic parent function, that's choice C, will look like this, even symmetry. No, your cube root function here, A, looks something like this. I'm drawing purple, odd symmetry. Kind of reflects rotationally 180 degrees. So A is our correct answer for 17. 18. For the graph function pictured below, what are the approximate coordinates of one of the local maxima? Well, if you look for the maxima, you're going to be either this one on the right or this one over here on the left. And if you go to answer choice B, if you go over 7, 1 to the right, 1, 2, 3, 4, 5, 6, 7, and up 2, you're going to go right here to this maximum. So B is our correct answer for number 18. 19. If f of x equals x plus 1 over x and g of x equals x, what is f of g of 2? And so what you do is you take this 2 and plug this 2 into the g. Okay? So g of 2 is equal to 2. And then we take this 2, okay, I'm going to rewrite f of x equals x plus 1 over x. You take this 2, and we're going to plug this 2 in for this x and for this x over here. So f of g of 2 is equal to 2 plus 1 over 2. Well, 2 plus 1/2 simplifies to 2.5, or 5 over 2. And so we write this in as 2.5, bubbling this in, and to do that we put a 2.5, and we don't have to place a negative sign in there. Next, problem 20. An elevation feet of punt football is given by a function ft equals 5 plus 74t minus 62 squared, where t is the number of seconds, to the nearest tenth of a second. Now, what are they asking for? They are asking for what? Seconds to the nearest tenth of a second. How long after being kicked? So let's go ahead. I previously graphed this one. If I go to Control I and graph this, we'll go up to. So here it is. Instead of t, I entered x. So we enter this and we see parabola, and we can't recognize it's a parabola. We know we have a quadratic equation. But if we go to menu, trace, we graph trace, we can go up to the very tip top and it says maximum, we have 2.31 comma 90.6. So let's go back here. We have 2.31 comma 90.6. And so what says how long? What does that represent? Well, when, I've told people this a lot, it's like when what? What does this mean, this little crossword puzzle thing? When what? It means that when refers to x values. We have how long. We're talking about the x value, time. And think about this a little bit. When you kick something up in the air, okay, a ball in the air, is it going to be staying in the air for 90.6 seconds? No, makes no sense. Then another little nicety, it says to the nearest tenth of a second. Well, actually, tenth of a second would be this first decimal place, 2.3. Now, usually you're not going to be penalized for putting in extra decimal places, but the thing is actually asking for tenths, and 3 is in the tenths place, so 2.3 is really the correct answer for this one, even though I saw a lot of people put 2.31 in here. But it is not 90.6. Sometimes they're going to ask for the height elevation. Analyze it, read. And if it's asking for what is the maximum height, well, then the answer would be 90.6. But when does it reach its maximum height? Sometimes they can also ask how long after being kicked does it return to the ground, which would be twice as long, 4.6 seconds. Now the last one, the rational function, achieve x equals x over x times quantity 1 plus x squared contains how many discontinuities? Mark your answer in the grid provided. Well, the answer is if you take x times quantity 1 plus x cubed, or x squared, excuse me, and set this not equal to 0, well, we know that x has to equal 0. Then if we set 1 plus x squared to not equal 0, we know we have a discontinuity where x equals 0, but we cannot have a solution for this 1 on the right. And so the correct answer for this is 1. We have 1 discontinuity here. Now, another thing you do to be sure is graph, and I previously graphed this. If I go to Control I, add graph, and we go to this, I know it's somewhere, here it is, that's it. And we don't see any discontinuities. We go to table view, Control T, we are not going to see any discontinuities either. We're not going to see a UND or U as undefined anywhere else but at x equals 0. That's going to be 1 discontinuity. That's going to be a point discontinuity, by the way, or a removable discontinuity. So that is our correct answer, and that's all of it. And I hope you work with me, especially on that one with the inverse function, the rational function, where I did a little wrong algebra but was bailed out by the graphing of it. Do similarly when you work on these tests. Good luck, and thanks for viewing.